Dear students, I am Khandaka Fazler Rabbi, lecturer, Milestone College, Uttara, Dhaka. Today, we discuss about aromatic compound aniline. What is aniline? Here, this one is ammonia. And this one is phenyl group. This one is also aryl group, and this one is aromatic part. When one hydrogen atom of ammonia is replaced by phenyl group, that means aryl group, then the compound is aniline. The name of this compound is phenylamine. And another name of this compound is aniline. This one is a primary amine. This one is amine, primary amine. Now we discuss about the preparation of aniline. Now, preparation of aniline from chlorobenzene. When ammonia reacts with gaseous chlorobenzene at 250 to 300 degrees centigrade temperature under high pressure and presence of cuprous chloride, concentrated cuprous chloride or cuprous oxide catalyst, then this reaction produce aniline. Now, preparation number 2, preparation of aniline from phenol. When phenol reacts with ammonia at 300 degrees centigrade temperature, presence of anhydrous zinc chloride, then it produces aniline. Now, preparation number 3, preparation of aniline by Hofmann's degradation reaction. When benzamide reacts with bromine and potassium hydroxide, this reaction produces aniline. This reaction is also called Hofmann rearrangement reaction. The overall reaction is the removal of carbonyl group from the amide. The product contains, this product, that means aniline, contains one carbon less than the original compound. Now, preparation of aniline by reduction of nitro compound. This one is nitrobenzene. When nitrobenzene reacts with tin plus HCl, then it produces aniline. At first, tin plus HCl reacts and produce nascent hydrogen. This nascent hydrogen reacts with nitrobenzene and produce aniline. Now, we discuss about aniline is a base. That means why aniline acts as a base. Structural formula of aniline is this one. In the nitrogen atom of aniline, there is a lone pair electron present. It can act as a donor of a pair of electrons and can act as an acceptor of proton. That means it can donate lone pair electron and can accept proton. According to Lewis concept, the compound which can donate lone pair electron is a base. Here aniline can donate lone pair electron and accept hydrogen ion and produce anilinium ion. So according to Lewis concept, we can say that aniline is a base. Now the question is, methylamine, ammonia and aniline, which one is more basic? At first, ammonia. Here nitrogen contains one lone pair electron and it can easily donate by nitrogen atom, and that's why ammonia is basic. But in methylamine, here nitrogen contain one lone pair electron, but this methyl group has plus I effect. Plus I, that means positive inductive effect. That's why this methyl group push electron towards nitrogen atom, and that's why the electron density of nitrogen atom increases and it can easily donate lone pair electron. But in aniline, here also nitrogen contain one lone pair electron, but this lone pair electron is used in resonance of benzene ring. If we see the resonance of aniline, here nitrogen push electron towards benzene ring and this electron shifts to this carbon. Here double bond, negative charge. This negative charge form one bond, pi bond to this carbon, and this pi bond shifts towards this carbon. bond form new bond, and this electron, pi electron, shifts to this carbon. That's why here negative charge occurs, and this electron shifts to here, and this pi bond electron shifts to this carbon. Negative charge. If we see the resonance structure of aniline, then we can see that the lone pair electron is used in resonance, and that's why here too, that's why this lone pair electron will not be available for donation, and for that reason aniline is less basic. So which one is more basic? According to our discussion, we can say that methylamine is more basic than ammonia, and ammonia is more basic than aniline. This now the question is why aniline undergoes diazo reaction but methylamine does not undergo diazo reaction. Here we see for methylamine, when methylamine reacts with nitrous acid, it produces methyl diazonium ion. Methyl diazonium ion. But this methyl diazonium ion is not stable due to resonance, and for that reason this methyl diazonium ion reacts and produce methyl carbocation and nitrogen gas. This methyl carbocation then reacts with hydroxyl ion present in the mixture and produce methyl alcohol, and that's why we say that methylamine does not undergo diazo reaction. But for aniline, when aniline reacts with nitrous acid, it produces benzene diazonium ion, which is stable due to resonance, and that's why it undergo diazo reaction, and the reaction is this one: NH2 nitrous acid plus concentrated HCl, 0 to 5 degrees centigrade temperature, and produce benzene diazonium chloride. This one is benzene diazonium ion. Benzene diazonium ion, and this one is benzene diazonium chloride. And for this reason, we can say that aniline undergoes diazo reaction. Now we discuss about some reaction of diazonium salt. At first, we have to know what is diazonium salt. Aromatic primary amine like aniline, when reacts with nitrous acid at 0 to 5 degrees centigrade temperature, forms a type of salt called diazonium salt, like benzene diazonium chloride. The formation of diazonium salt is known as diazotization. Now, reaction of diazonium salt. At first, preparation of phenol. When benzene diazonium chloride reacts with water, warm water, then it produces phenol. Second reaction, preparation of benzene. Preparation of benzene. When diazonium salt is reduced by hypophosphorus acid, this one is hypophosphorus acid, then it produces benzene. Now, preparation of aniline. When diazonium salt is reduced by zinc and hydrochloric acid or lithium aluminum hydride, then produce aniline. Preparation of chlorobenzene. This one is fourth reaction. Fifth reaction, preparation of chlorobenzene. When benzene diazonium chloride reacts with cuprous chloride and their corresponding halogen acid, then it produces chlorobenzene. This reaction is known as Sandmeyer reaction. If we use cuprous bromide, then the product will be bromobenzene. And if we use cuprous iodide and here hydrogen iodide, then the product will be iodobenzene. And this reaction is known as Sandmeyer reaction. Now, preparation of benzoic acid. When benzene diazonium chloride reacts with cyanobenzene by the presence of hydrogen cyanide, then cyanobenzene is produced. This one is cyanobenzene, and this if this cyanobenzene is hydrolyzed by the presence of hydrochloric acid or mineral acid, then it produces benzoic acid. This one is benzoic acid. Okay. Now the question is, the nitration of aniline take place at meta position. Explain. If we see aniline here, the substituent is amino group, NH2 group. This NH2 group is ring activating group. That means this one is orthopara directing group. But in nitration, this aniline takes proton from acid and it produces anilinium ion. This group is meta directing group. That's why we get meta product. Why this group is meta directing group? If we see the resonance of anilinium ion, this one is anilinium ion. If we see the resonance of anilinium ion, then we realize this NH3 plus NH3. This electron shifts to this bond, and here one bond formed. This carbon is positively charged. This electron shifts towards positive charge, and we get like this shape here, bond. We get positive, this electron shifts here, bond, positive, and now this electron shifts here. If we see the resonance structure, we see that by the presence of NH3 plus ion, the electron density of orthopara position, this one is ortho position, electron density decreases. That's why this one is meta directing group, and for this reason we get meta product from nitration. Reaction occurs, NH2 like this way, HNO3 concentrated nitric acid, H2SO4 concentrated NH3 anilinium ion, concentrated sulfuric acid, and we get meta-nitro aniline. By the presence of nitric acid, this hydrogen ion is accepted by NH2 group and we get anilinium ion, and nitration places, and the product is meta nitro aniline. Now the question is between difference between methylamine and aniline. Here methylamine, aniline. First one, methylamine reacts with nitrous acid and produce nitrogen gas and alcohol. Here the reaction alcohol and nitrogen gas. Aniline reacts with nitrous acid and produce nitrogen gas and phenol. That means methylamine produce alcohol, but aniline produce phenol. Second one, methylamine cannot produce diazonium salt, but for aniline at 0 to 5 degrees centigrade temperature and dilute HCl, aniline reacts with nitrous acid and produce diazonium salt. Here the reaction aniline reacts with nitrous acid and hydrochloric acid at 0 to 5 degrees centigrade temperature. It produces benzene diazonium chloride. This one is benzene diazonium chloride. And third one is it does not, that means methylamine does not form any precipitation with bromine water, but in aniline it forms white precipitation with bromine water to form 2,4,6 tribromo aniline. This one is 2,4,6 tribromo aniline. Now identification of aniline. If aniline is heated with chloroform and alcoholic potassium hydroxide, then it produces offensive smelling compound phenyl isocyanide, and this compound is also named phenylcarbylamine. By this reaction we can identify aniline.